So the next progression after we've used both the molar mass and the Avogadro constant as conversion factors is to put these two together. And so in so doing, we can use both these conversion factors to go from, say, chemical entities all the way to mass, or vice versa, go from a mass of a substance to the number of molecules, for example. So we'll do that. First thing I want to show you is something known as the mole hub. And so the mole hub is just a simple little visual that might help you find your way, so to speak. It's kind of like a bit of a map. And so at the top center of the mole hub is the mole, symbol N. And so I've already seen we can get down to entities. And these entities, if you recall, are things like atoms, molecules, or formula units, ionic formulas. We have already seen we can go from moles to chemical entities using the Avogadro constant, and to do that we multiplied by Avogadro constant. Remember, mole is typically a smaller number, entities is a huge number, so we multiplied by that huge number. And we also saw we can go back the other way and we just do the opposite. If we want to get from entities to the number of moles, we divide by the Avogadro constant. Well, similarly on the other side, we've seen that relationship between moles and a mass in grams, and that's the molar mass. And so if we have a number of moles and we want to get to a mass, we multiply by the molar mass. And conversely, if we want to find the number of moles and we're given a mass, we divide by the molar mass of that substance. And so this little mole hub is useful in certainly when you're trying to figure out these problems, because you can find out where you're starting and then use the correct version of the conversion factor to get around the mole hub, to find moles and entities or whatever. Alright, so let's just try a couple of problems. So here's a question: how many molecules are there in 0.75 grams of oxygen gas? And so there's the molar mass of oxygen gas, 32.00 grams per mole, and there's the Avogadro constant. And we're going to have to use both of those conversion factors. Those are the two conversion factors. So we'll do this in two steps. So if we're starting with the mass, the first thing we want to calculate is number of moles of oxygen. And so how do we do that? Well, it's mass times a conversion factor. And so that conversion factor is the molar mass, so it's going to be 0.75 grams times, now I want to get rid of grams, so that's where I put 32.00 on the bottom, and I have 1 mole. On top, grams divide out, and I'm left with a value in moles, and that is 0.0234 moles of oxygen. So now I have moles, so if we quickly zip back here, I'm at the top of the mole hub now, I'm at moles, and I want to get down to chemical entities. In this case it's molecules, so I'm going to use the Avogadro constant. So number of molecules of O2 is going to be my number of moles, N, that I just calculated, times conversion factor. And so that conversion factor is the Avogadro constant now, so 0.0234 moles times 6.022 times 10 to the 23rd molecules. That's the entity I'm looking for, so I define it here, molecules per mole. And so moles divide out, and I'm left with the number of molecules. And that's 1.4 times 10 to the 22nd molecules. Notice the correct number is sig figs. 2 sig figs in my answer. 1.4 is 2 sig figs because 0.75 grams given is 2 sig figs. So that's using the mole hub. Let's look at one more example. So if somehow you could determine the number of formula units, the salt in the salt shaker, you might come up with a number like this, perhaps not, as we'll see in a minute. 8.723 times 10 to the 24th formula units in my salt shaker. What would be the mass of salt in that salt shaker? So I'm going to cover this one in one step. And so one step, again, what are we looking for? Mass. So mass of NaCl equals. Well, what am I given? What am I starting with? I'm starting with the number of formula units. So number of formula units is my given. And I'm going to do this in equation form. So to go from formula units to moles, I divide by the Avogadro constant, and that's shown back here. Here I start with entities, formula units in this case. I want to get up to moles, I divide by Na. And so there I am dividing by Na. And to get from moles to mass in grams, I multiply by my other conversion factor, the molar mass. And so that's how you can show it. That's a formula equation. And I can now substitute and do the calculation. So 8.723 times 10 to the 24th formula units divided by my Avogadro constant, 6.022 times 10 to the 23rd. Units are formula units per mole. And those formulas divide out. I'm at moles now when I do that math, and then I multiply by my molar mass, 58.44 grams per mole. And now moles divide out. I'm left with the unit of gram, which is great because I'm looking for mass. And the mass is, to the correct number of sig figs, 846.5 grams NaCl. That's a very large salt shaker if you have almost a kilogram of salt in there. Anyways, that's the use of the mole hub. The mole hub allows us to move between mass, moles, and entities, and both directions, and so it's a very useful concept to come to terms with.